What's up, everyone? It's Eric with Option Edge, and today we're going over theta, okay? This is one of the most important option Greeks that we can learn, so let's get into it. It's been a while since I've done one of these videos, so let's get back to it, okay? Theta. So what is theta? What is the definition? So it's the daily decay of an option's extrinsic value, otherwise known as time decay, and it is the first derivative of the Black-Scholes model with respect to time. Okay, Black-Scholes model is the mathematical model that gives us the option prices. You don't really need to know that though. Time decay and intrinsic value. So like we said, theta is the decay of extrinsic value. Well, extrinsic value is composed of volatility and time. So theta is chipping away at the time part of the extrinsic value. And an intrinsic value has no time decay, okay? So let's look at the different signs of theta, okay? So if you are positive, if you're positive theta, that's another way of saying I am short options, okay? This means that if you're selling, so when you're selling an option, you're actually benefiting from theta decay, time decay, because each day, as time goes on, there's going to be a certain value that the option loses, okay? And this has everything to do with the fact that options have an expiration date, okay? They expire, unlike stock, which does not expire, okay? You can hold stock for 100 years and there's no theta decay. So when let's go back to positive theta. So if you're a net seller of options, that means your theta symbol would be positive and you're going to benefit from that time of decay. And then I also wrote down here that as a seller, something you have to be mindful of is volatility expansion, because if volatility expands, the option price of a contract will also go up. And as a seller, you want the options contract to go down. So that's why you want your time decay to be greater than, in order to be profitable, your time decay has to be greater than the volatility expansion if we're holding the stock price the same, okay? So, and I just touched on this a little bit. So stock has no expiration date, no time decay, therefore no theta, okay? But options, on the other hand, do have an expiration date, therefore there is going to be a time decay. And that's because as options approach their expiration date, they're either in the money or out of the money. If an options contract is out of the money at expiration, it is worth nothing. If it's in the money, it is worth something, okay? So that's something to keep in mind. So let's negative theta, okay? So this is the opposite of selling options. If we're buying a call, if you're buying a naked call or a naked put, that means your theta would be negative. So that means time is against us, okay? So as time goes on, we're losing money if we hold all the parameters of an options contract equal. If we hold the stock, the stock price doesn't move, volatility doesn't move, each day we're going to lose a little theta. I'm going to show you sort of what that looks like in a little bit. So the reason why this is so difficult, this is why I advanced options traders are not buying calls and puts, just straight calls and puts. They're either hedging it by selling under an option, or they're actually selling. Their portfolio will be mostly comprised of positive theta rather than negative theta, because time will be on your side. When you're negative, when your theta sign is negative, time is against you. So if you are, you have to be directionally right. So if let's say you buy a call on Tesla, 30 days to expiration. Okay, if Tesla takes a dip by 10%, well, hell, the odds are stacked against you. Not only has the stock moved against you, but now you also have theta chipping away every day at the value of your option. Okay, and so we talked about this with positive theta. If you're negative theta, if you're long options, if volatility expands and we keep the stock price the same, then and volatility is greater than the theta decay, then you actually will profit. Okay. So next. So there are risks with theta, okay? So you might say, hey, that this theta decay thing sounds good to be a seller of options. You have time on your side, but there's also gamma risk that comes with that. If you're if you have a lot of theta, high theta, very positive theta portfolio, then that also means you're going to have high gamma. Okay, so something to be aware of. Gamma is the risk of an option contract. It's that risk from going in the money to out of the money. Okay, and as a seller, you want your options to stay out of the money. So let's talk about out of the money options versus in the money options and their theta decay. So most options are at the money or close to at the money. And what you notice here, if we look at this red line, is that you see sort of a linear theta decay. You see a little bit of a curve. And then when we get to this inflection point, this is about the halfway point in an options. So if you have a 60-day contract right around the 30-day mark, the option will start to decay exponentially. Okay, so this is another thing to be cognizant of if you're a call or naked put buyer. All right, so if you buy a call, let's say you buy Apple's trading at $100 a share, you buy the 120 calls and they're 60 days out. Okay, let's say this option has like a delta. That means the delta would be like around 30. If Apple just stays for the first 30 days, doesn't move, let's say, or if it even moves $5 over that span of time, by the time you get to that halfway point, you have to overcome this exponential decay to make money. Okay, so it's very difficult, and so this is just showing you that in the money options don't really have much. They have a linear theta decay, and that's because in the money options are primarily composed of intrinsic value, and intrinsic value doesn't really have decay. Okay, only that an extrinsic value does. Okay, so this sort of is a good diagram. So let's look at let's actually look at the Greek on this is Robinhood. So we're looking. This is the November 19th. 149 call options. The current price is right at 148.50. So we are one strike out of the money. We're basically at the money. Okay, our delta is smack right at 50. So you see our theta is almost 0.67. Let's call it 7. Okay, so it's negative theta. Okay, so that means we would be buying this. All right, if it was positive, that means we'd be selling this. What does this mean? What does this number mean? So remember, options have 100 contract multiplier. So when you look at this $3.60, that option contract costs not $3.60. It costs $360, $360, right? Because you're multiplying this times 100. So we're doing the same thing with all the Greeks here. So theta, we're going to multiply that by 100. We're going to get negative 7. Okay, so what's that mean? That means every day this option contract is going to lose $7 or 7 cents, depending on how you apply that. Or if we apply the multiplier, it's going to lose $7. So if we hold volatility equal and we hold the stock price equal, and 1 day passes, this options contract will go from being 360 to about 353. Okay, because we're minusing 360 minus the theta 7 is going to be 353. Okay, so hope that makes sense. And this is just showing basically what I just explained. Theta is the option Greek that expresses the theoretical decrease in value of an option contract with the passage of 1 day's time. So this is showing the same thing. We have $5 theta or 5 cent theta in 1 day time. After a day, that is going to be the contract's going to be worth 95. Okay, that's if we hold the stock price and volatility equal. Okay. And this is just showing you another example of Tesla. So Tesla's it's a $909 stock, and look at the size of the theta. Okay, it makes sense that theta is going to be bigger. There's going to be more decay for a more expensive option. Okay, that makes sense, right? And this is also at the money. And let's before we get into let's look at more Robinhood examples. So I'm going to go into the Robinhood option chain here. Okay. So we're looking at the November 19th Apple options contracts. So if we look at, we're selected, we have calls selected. So let's go back to our one out of the money option. So this is the 067 option if we go down, if we go down once, basically the one strike in the money and one strike out of the money are basically the same. So let's go out of the money more, okay, and let's see how our theta changes as we go out of the money, okay, see how that value changes. So let's go to 170, okay, so this is very far out, so you can see our theta is about 2, okay, so at the money options, out of the money options have a low theta, okay, compared to our at the money options. Now let's go in the money. If you remember on the graph what I showed you, you remember that in the money doesn't have as much theta decay because it has more intrinsic value, and as you can see, this has a theta of 3. Okay, so that means at the money will always have the most theta. Okay, and then we talked about how as time goes on, theta tends to become more and more, it becomes exponentially large. So it gets more and more negative. So the current date is October 22nd. So let's go to the nearest term contract, and we're going to compare the 149 calls to the nearest term contract, which is, let's go, this is today. So we'll go next week's contract. So let's see what the theta is. Theta was about 7. Let's look at the theta here. All right, theta is 17. Okay, so that shows you how as we get closer to that expiration date, theta really tends to kick up. Let's check out what today's was. That's going to be 0 because today passed. But then let's go out to we'll go a couple months out and look at. Okay, this doesn't have the same strikes. Let's see if we have the same strikes here. This doesn't have the same strikes either, but you get the point. Theta's only about 5. Okay, compared to 7. All right, so I think you get the picture, you get the idea with that. So let's continue our slideshow. So another thing to keep in mind is theta. What happens to theta before earnings? So this is like a special occasion. I figured I'd throw it in. So let's read here. Implied volatility can reduce the negative effects of theta because before an earnings event, earnings cause option implied volatility to go very high. Okay, so let's keep reading. Extrinsic value decay close to earnings is diminished by this elevated spike in implied volatility. So if you remember, extrinsic value is comprised of time and volatility. So basically what's happening is volatility is increasing and mitigating the effects of theta decay. Expansion volatility causes option extrinsic value to decay slower. Okay, so it's sort of same thing. So that's just interesting phenomenon that happens before an underlying's earnings to the options contracts. The theta isn't quite as pronounced, and you can do some interesting things because of this phenomenon. So once again, theta decay is not linear. You can see this is, I should have put this ahead, but yeah, as you can see, right around that halfway point is when we really start to fall off a cliff here. So just reiterating more of what I said before. And then these are a little bit out of order, but so here we're looking at theta decay before earnings. So this before earnings theta decay is going to be more linear, okay, as you can see, or it doesn't even decay here. It doesn't really even drop. And then right before earnings, right after earnings, you're gonna have a big drop. Okay, so that's something else to keep in mind. So here's some going deeper in theta. We're looking at different deltas of this is the S&P 500 and seeing how that affects theta decay. So if we look at this, we hold the delta constant on a percentage basis. The further out of the money options decay faster than at the money options than taper. Okay, so what this is saying is if you if you're selling let's say you're selling a 5 delta call. Okay, what this is showing is that you're going to reach 50%. The value of that call that you're selling is going to decay by 50% faster than an at the money call. Okay, so that's good if you're a option seller, right? And bad if you're an option buyer, because what's going to happen is if you're buying options, it just means your theta decay is going to get really eaten up quick. Okay, but that doesn't mean. Well, let's compare that to the next slide. Okay, actually, before we go to the next slide, so yeah, 5 delta, you can see decays. It takes about 17 days to get to that 50% decay on average. And then if we go to right at the 50% mark, 50 delta, it's going to take about 35 days to hit 50% decay. Okay, so something to keep in mind. But that doesn't mean that you're making more money necessarily. So if you want to make the most money, then if you want the most theta decay, then you're going to want the at the money options. And I think we showed this on Apple. The at the money options had the largest theta decay, but you also have the most risk, right? With more theta decay comes more risk. All right. So you can see that 5 delta makes the least, 50 delta option makes the most. Okay. And that's sort of the gist of our little slideshow, all things theta. Hope you guys like that. If you have questions about theta or any of the other Greeks, please comment. I like to answer you guys' comments. And this isn't investment advice, just me trying to be an educator. All right. Hope you enjoy your weekend. Peace out and see you next time.